Hi folks, welcome to our review session for Calculus 2. Today we're going to be covering material involving integration by parts, trigonometric integrals, trigonometric substitution, partial fractions, improper integrals, and then also some error bounds on approximating integrals. As always, if you have any questions, there should be a chat box appearing somewhere on your screen. Please post those questions inside that chat box. So you're more than welcome to go ahead and ask those questions, and that's my main reason for being here. So if you have those questions, ask them and I will be happy to address them during the broadcast. So without further ado, let's go ahead and get started. So our first problem here, we have the integral we want to solve here, this indefinite integral of dx over x squared times the square root of 25 minus x squared, that whole quantity appearing in the denominator is that x squared and that square root of 25 minus x squared. So with that in mind, what's our approach here? Well, notice we see a square root, so that should be screaming something at you. And in fact, the thing that should be screaming at you is that we are going to use a trig substitution. Now, the key to these, if you have something like a squared minus x squared, where a is a constant, then usually what we try and do is x equals a sine of theta. If you have something of the form x squared plus a squared, just an FYI, the appropriate substitution is usually x equals a tangent theta. By the way, on the a sine of theta, you could actually have used a cosine theta. It just makes your derivatives to be a little bit more wonky, I guess it would be the word, meaning you'll have a negative value appear in there. And then last but certainly not least, you can go x squared minus a squared, and then an appropriate substitution would be x equals a secant theta. Okay, so those are our three sort of scenarios. And in terms of, and by the way, with the x equals a tangent theta, another one you could use is x equals a cotangent theta. That's an appropriate substitution. And then for the x equals a secant theta, the other substitution you could also use is x equals a cosecant theta. So all those are options, but in terms of, these will be the main three that we deal with. You don't have to worry about the others. So if you look, we have 25. What is that? Well, that's just 5 squared. Okay, so since we have 5 squared down below, we can say that x equals, we want to use a sign in this case because since it goes 25 minus the x squared, so this should be 5 sine theta. And immediately after you calculate it, you probably want to get in the habit of doing a dx. So in that case, dx equals 5 cosine theta and then a d theta. Alright, so now we have things set up for us, and I'll erase that little piece there. We'll use it again later on another problem. What happens? Well, so we can rewrite this integral. What this integral becomes is the integral dx is 5 cosine theta d theta. And down below, what do we have? Well, x squared, that's going to be 5 sine theta, the quantity squared. And then we have the square root of 25 minus, and then we'll have 5 sine theta, the quantity squared again. Okay, so simplifying this, what do we have? Well, we get 5 cosine theta d theta we have a 25 sine squared theta. Notice this is a 25 sine squared theta over on this side too. So you can factor out the 25 out of both of those inside the square root. So you can write this is a square root of 25, factoring that out from both pieces. 25 times what will give us 25? Well, it'll be 1. And then 25 times what will give us 25 sine squared? That would be sine squared theta. And the whole idea behind that is the fact that this 1 minus sine squared theta is cosine squared theta. So we can write this as 5 cosine theta d theta. And then we have 25 sine squared theta. And then this should be the square root of 25 cosine squared theta. Now some beautiful things start to happen. Okay, so we can, first off, you can cross off that 5 up above with the 25 down below and take that 1/5 out in front. So we'll make this 1/5 times the integral. Notice we have cosine theta d theta. We have a sine squared theta. And then we'll have square root of 25 is 5. And then cosine squared theta, if you take the square root of that, you're left with cosine theta. Technically, I should worry about, is it going to be plus or minus in those intervals for the cosine? But we'll be all right now, just as is. So what does this become? Well, you can pull the other 5 out in front. So what do I mean by that? Take this 5, move it out in front. So 1/5 times 1/5 is 1 over 25 times the integral. We're left with cosine thetas will cancel. And so we're left with 1 over sine squared theta. Oh, d theta. So another way for us to write that is just 1 over 25, and then we take the integral of cosecant squared theta, d theta. And we know the antiderivative for cosecant squared. That's not too bad either. So the antiderivative for cosecant squared should be negative cotangent, because cotangent's derivative is negative cosecant squared, so that's how we account for the negative portion. So this is 1 over 25 negative cotangent theta, and then plus some constant c, right? But we aren't done yet. It seems like we're done, but we're not. We have things in terms of theta. That's good. Everything's hunky-dory. So now, here's where we got to change our game plan. We got to use this x equals 5 sine theta. Okay. If x equals 5 sine theta, notice that means that x over 5 equals sine of theta. And what that allows us to do is draw a triangle. So we have some angle theta, and sine is opposite over hypotenuse, so that means the x goes on the opposite side and the 5 goes on the hypotenuse. So that means that over on this side, you will see using Pythagorean theorem, so this side plus x squared equals 5 squared. So if you want to solve for this side, it would be 5 squared minus x squared, taking the square root of that, and 5 squared we can more easily write as just 25. Okay, so we're in pretty good shape now, and we have our triangle, and we want to try and convert the cotangent of theta. So what is cotangent? Well, cotangent of theta is just 1 over tangent theta, and tangent theta is opposite over adjacent, so this means this is adjacent over opposite. So the adjacent side to our cotangent, dealing with the cotangent theta, so where theta is, adjacent side is the square root of 25 minus x squared. So we have negative square root of 25 minus x squared. And then what is our opposite side? Well, it's just x, and then we put a plus c, and bada boom, bada bing, we are done. Okay? Questions on any of that? And for those of you that have just joined, there's a little chat box over on the side. Feel free to ask those questions there as well. So I don't see any questions popping up just yet, so we'll keep on moving forward then. In our next problem, we're going to try and solve an integral cosine squared theta